Let's wait until it shows that recording already begins. Okay. All right. So let's actually begin. Today is an introduction for the class. And before I begin the first content that I want to cover today, let's talk about admin stuff, right? The first most important thing is we have a class website. As usual, we'll be doing this on Canvas, right? I think most of the lecturers at the CS department are using Canvas, so this is probably all familiar by now. The link is both in Discord as well as the Sky announcement. So if you don't really like how Sky work, like myself, you can check out the Discord channel. We also have a Discord channel called Parallel Programming, and no, I think it's functional and parallel programming. So that's where we will sync up regarding any announcement. So we will post basically announcement on Canvas. I'm gonna have another announcement on Discord. This is where all the information for this class is posted, including the policy, syllabus, schedule, announcement, and assignments. So any question about the class website, basically it's LRW for EJ. That's the sign up code. If you haven't done so, please do so. If you already signed up for the class, everything will be up there. All right, so let's go to the next big thing, class policy. First of all, no plagiarism. Everything should be from your own work. And if you look up sources online, consult your friends, you need to put proper citation or references to all those sources. It actually helps me, think of it this way, right? It helps me preventing you from being penalized, because I know, okay, you look up these sources and this is what you got for your, say, solution. I'll be more than happy to actually integrate this additional learning. Basically, every time you go to Google, right, and you try to figure out and answer the problem, the way the class is designed, there's no direct solution. You have to actually think, like, there's actually additional thinking steps in between. As long as you don't stare at your friend's monitor and carbon copy the program, there's some learning that you actually did, right? But you all know how the plagiarism policy works. My own policy is if I have somehow caught you cheating, this is what I'm gonna apply. Instead of just getting 0 for the assignment, you're gonna get the maximum of that grade for the assignment, number of times you got caught, negative value of that. So let's say assignment is 10% for assignment 1. You got caught cheating, you get negative 10% to your grade. Basically, that's 2 letter grades down, right? So don't do it. This is serious, right? This class is designed for juniors-ish like students. You're third-year students. You should be responsible for be able to write your own code, be able to invent new things. And this is what we really want to make it clear in this class. We have class project, which we will talk about a little bit later. Basically the content of this class compared to earlier class that you've been taking is morphed into both assignments, which are things that are basic knowledge that we want to make sure you understand, into invention, which is what you do once you graduate and actually becomes a full-fledged programmer, right? You want to be able to actually invent and do a project on something you're passionate about, something that you have curiosity on, something you want to invent, right? We are inventors here. That's what most computer science and computer engineers are being classified as. You have 5 late days in total. You can use 2 per assignment. There are likely 3 assignments plus a project. So you can kind of distribute those 5 days across all these four assignments. 3 for the main assignments and 1 for the project. Office hour, this is a little bit tricky because I need to kind of check my schedule starting in May. Basically, the semester at TGS where I'm teaching, but basically my main university, because I'm part-time. That's actually another reason why I don't have the right now WebEx account. Basically, they disable all the part-times until further notice. So The science division is still working with the MUIT department. I don't know what's going on over there. It might take some time. Yeah, I don't know how to expect part-time to teach without the proper like online classrooms account. Luckily, I still have this Microsoft Team as a backup. Office hour will be on Discord, but I'll announce it around the beginning of May, where the semester at TTJS is ending. So I know exactly what my schedule would look like. I need to sync up with my master and PhD students and what would be their preferred time for my one-to-one meeting with them. I also need to make sure I sync up with the new interns that comes to my lab during summer. So I need to kind of make sure I have those time slot scheduled before announce my office hour. So bear with it. It should be at most 1 more week, right? I'll likely have 1 to 2 slots a week. It should be half an hour, but if half an hour is not long enough, I might just do 1 hour, 1 slot per week, right? My experience so far is there's no one in the office hour until the day before the assignment is due, right? So make sure you load balance that quite a bit. Make sure you treat office hour as the time you can come in and talk about anything, not just assignments. I encourage you to discuss material with your classmates and work together, but each student must write your own code, right? And you need to clearly indicate who you have worked with. This is important because, again, treat it as a way for me not to penalize you. All right, any question about the class policy? Basically, if you've taken class with me before, you know my policy. And it's likely the same policy as everyone else in the CS department. I mean, the CS program here. Ajahn Kanat, Ajahn Santhern, Ajahn Piti, and Ajahn Boy, right? Everyone roughly have the same policy on plagiarism, which is they're bad, don't do it. Otherwise, you're going to get penalized heavily. And here's a grading breakdown. Assignments likely will be 3 assignments, so it'll be 10% each. In total, they're 30%. There's a project that are 20%. In-class exercise. This is something that I find transition you between I kind of know about the topic from the lecture to I'm a little bit more comfortable tackling the assignment. So the in-class exercise is 10%. You know the deal about my policy regarding in-class exercise. I'll put a due date where it makes sense. For example, the due date would be for the in-class today, the due date is literally today or next week in most cases. I really encourage you to meet that due date. If not, you still have the time to work on it until the end of semester. I really, 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 really want you to work on this in-class exercises. There's no penalty in submitting late. The only thing you're gonna get penalized for is you haven't started in-class exercise, and then you run into assignment, you run into quizzes, and you're screwed because you don't know how to work on the assignments or quizzes because you don't really know the basics from the in-class exercises. So again, encourage you to do in-class. Usually what we do, we migrate over to Discord. I'll lose about 70% of the students here for some reason. I encourage you all to migrate to Discord when you do in-class exercises. That allows us to have a proper discussion, chat, troubleshooting, trying to guide you, even advising. Somehow just like all the random questions get asked, which are awesome. I like discussion, right? And then 20% midterm, 20% final. I need to call it quizzes because it's be a part of the class, or I can schedule it anytime you want. The reason I said I want to schedule quizzes at any time you want is I want to avoid conflicts with other exam. Right? This is for your benefit. I tend to do this in the past 3 semesters. Every time I teach at MUIC, I basically ask like, hey, what's everyone's schedule? Do you prefer this date or that date or that date? I'll try to make sure it works for everyone here. And I can curve anything above to make sure everything is fair. Basically, I want to make sure I don't overly make a class too easy, or in many cases that happen to all my classes, make it too hard, right? So I'm gonna cover, I'll look at the curve. I'll look to see how do I curve it. Any questions so far before we go to topics that have been covered in this class? Otherwise, Phil, the first topic we would cover is what we call functional programming, right? What is functional programming? The way we treat programs so far is we treat programs like the iterative command that the programmer asks the computer to do, right? What will happen if I say printf? The computer would go and print something on the monitor, right? Functional programming treat program like maths function. Can you raise your hand here if you like maths? No one raised their hand. What about if do you hate maths or recursion? Come on, let's be more interactive. Anyone still here? All right, who would like recursion? Yep, no hands. Oh, that's one. Awesome. If you like recursion, you might like this class. That's a really high chance that you're gonna like what we're gonna cover, especially for the functional programming part. All right, someone's typing, so see if there's any additional response. Whoop, no one's typing anymore. So it's okay. That's an awesome response to that. Who hates recursion? I noticed quite a few people of you like I hate recursion. I don't know how to like logically think about it. All right. So okay. So it's a totally fair game to hate recursion, right? And we'll go through this together. Don't panic. Don't panic. So first of all, don't panic for sure. I want to make sure that you are aware that recursion is a form of maths. Anyone might have recalled this thing called induction? It's something similar. You start with the base and you build from there, right? So we'll cover how you can write a program without a loop, but we use recursion instead. There's a way to actually build programs that way, right? And there's not just beauty behind it. I know like a lot of math people, when you talk to math people, it's like, oh, this thing's beautiful. I personally hate math. The reason why I go do computer architecture, which is where I basically I would call this is my expertise, right? I hate math for a reason. I'm not like for example, I'm not a John Kanat who like look at algorithm and kind of invent new things. Nope. I want to build things. I want to design a computer. So, but recursion, functional programming, and things that we are doing right now for this class translate to one of the most important thing, if not the most important thing in computer science, performance. Anyone here want performance in your program? Can you raise your hand if you want to write a program that is fast? Awesome. I can show you one example of the program that is super slow, right? So I have this. This is my basically it's the housing project I'm in from AP, the housing company. And this is the app here. And if you look at it, there's a chat function, right? So if I click the chat, it takes forever to bring up the chat. Oh, this is faster. This is interesting. Usually it takes forever. This is how you should not ever write any piece of program. So if you're going to this class, we will talk about how to make your program faster. What are the common pitfalls in writing programs that becomes slow? This class, as well as a composite art, which is another class that offered this semester, is like we all focus on making computer more featureful and fast, right? Another use case of like making things fast is everywhere in your mobile phone apps nowadays. They're not really efficient in many of them, right? So functional programming are one of the construct that allow you to write fast program. Another thing that we cover is we'll go into this thing called parallel programming. You'll talk about the basic of it. So we will build you up from things actually we'll learn today what we call data flow programming or data flow model to make a good way to think about the algorithm that would enable parallel program. And if time permits, I'm gonna cover more advanced topic, right? Oops, and I forgot one thing. Animation bug. The first thing is the basic element of the programming languages. So I'm curious, like, why is that bullet point is gone? So the first thing we cover, what is a programming language? Why do we care about it? Why do we hate C? And why do we like Python? And then we go to parallel programming, basic parallel program. And if we have time left at the end of this semester, I will talk about the current trend in parallel program on top of Rust, which is a really definitely great trend. But the things like GPU programming is actually coming from one of the parallel programming paradigm, right? That makes say machine learning really fast. I can tell you as a hardware guy, like the reason why machine learning is possible even is the advance in parallel program and the hardware. The Turing Award lecturer who got the Turing Award for machine learning actually mentioned that too. Without hardware, there's no machine learning. Without parallel program, there's also no machine learning. All right, so let me cover the assignment a little bit, right, while someone is typing the question. So if you have questions, feel free to type it in. Feel free to raise your hand as well. Anything that would make learning better. I know online learning is not perfect. It's far from perfect, actually. The only thing I can rely on is this like little tiny pen that I can draw. It's not the same as whiteboard, right? We actually managed to have a live session finally last semester for like a month. I'm so happy, but now it sucks again. Anyway, so we cover assignments, 3 to 4 assignments, likely 3. The submission is done through the SysQ server in the folder called hand in parallel AX, where X is the number of assignments. So the first assignment will be A1, second assignment A2, etc., etc., etc. If you took my system skill class, you should be able to log in using your old account. I haven't deleted anyone's account, so feel free to use it. If not, ping me. Let me know so I can create your account. So this is your assignment for today. If you cannot log into SysQ, please let me know so I can create your account. All right. Your code, we set it up such that you can develop on your IDE locally on your machine in any way you want. But one extra thing that I would really need to ask this semester, because we have a lot more students, is that your code should be runnable on SysQ. What do you mean by that? Make sure you copy your assignments on your SysQ server's home path. Try to run it and see if it works. This would actually allow me to grade much faster, right? Because it allows me to centralize all the environment with Unix-based setup for both Scala and Rust-based projects. So we have class project as well. It's open-end, so you get to build whatever you want. This is I'm stressing that, whatever you want, right? But I should be utilizing your knowledge that you learned from this class, right? Basically, functional programming and parallel programming, anything that would make your program faster. So you kickstart after the midterm, right? We'll kickstart this formally after the midterm. But you're all welcome to discuss your idea as early as now. So some of the potential idea is, if you have a program that you're passionate about, if you have an algorithm that you're like, oh, I like this algorithm, but somehow this is the algorithm that feels like it's nice, write a parallel version of that. Okay, so for example, there's a project on parallel merge sort. And one of the students who actually did a senior project with me as well did well, basically, he talked to Ajahn Kanat. He got a paper from Ajahn Kanat, and he was like, okay, I'm going to implement this. So this is a little bit extreme. You don't have to go that far, right? But basically, my key message, follow your passion. If you have something that you like, if you have a program, piece of program that you like to work on, one of the potential project idea, make that program faster. Just make the program faster through parallel programming. And I can assure you, if you know how to do this, or something like learn how to use CUDA on a GPU. Anyone here heard about CUDA? This thing? Or anyone here heard about running things on a GPU? That's an awesome question. So, no, there's no special process. Well, let me go through this a little now. Now that one thing I love to do, I go sidetrack all the time. This is the first instance of this class that I'm gonna go sidetrack, right? So, what is a GPU? What is the main use of GPU? And hopefully, it is interesting for you all. So, I'm gonna talk about it from the hardware point of view. Why do I need a graphic card? Why do I even buy a graphic card in the first place? To render graphics, that's an awesome answer. Informally, I buy it to play games. I mean, there's no age limit on playing games. I still buy them. Well, I still play them too, right? It's a dedicated hardware to render a frame. What is a frame? It's one image on your screen. How many of you here have a 60 hertz monitor or 72 hertz monitor? Well, everyone will have one of the two versions, right? Either 60 hertz or 72 hertz monitor. What does it mean? It means that within 1 second, the screen is capable of showing 60 images. Every 1/60 of a second, you show one image, and then you go to the next image. You show the next image. That's how you, or basically that's how you can watch a video, right? Or anything on your screen. What does it mean? It means that the computer has to be capable of drawing that image. Within 1 second, they need to be capable of drawing 60 different images, right? And there's a lot of number crunching. When you want to draw something, what's the basic mathematical, I guess, area that's involved in this part of number crunching? Do you use probability? Do you use geometry? Do you use number theory? What's the main one? Is geometry. You draw things like triangles, right? You figure out, okay, between this dot and this dot, what's the equation of the line that connects to the two dots? Are those two lines crossing? If they do cross, which line should I show? Which one is in the front, right? So it's a lot of repeatedly add and multiply. So if you look at geometry, it's add and multiply, right? So where am I getting with this? A GPU is a piece of hardware that are capable of running multiple instruction that has the same operation. It has the same operation. Add, multiply, 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 multiply. Right? So that's what I use the GPU for. All right. Yeah, 2000, I would say CUDA is 2012 come in. What happened? Well, you talk to people who do want to do machine learning at the time, right? Or do scientific computing, linear algebra, right? What are the main operation? When you have to do matrix multiply, what do you have to do? All right, now let's go a little bit more technical here. Come back from our game world. If you have to do a matrix multiply or multiplying a bunch of things. What are the main operations in here? Multiply and add, right? Multiply and add, same thing. So think of it this way. You can now use the GPU to do matrix multiply, which is the main component of many scientific applications, including machine learning. So if you know how to use a GPU, you can then write not just use the machine learning, right? There's a part where you become the user, you pick up PyTorch or TensorFlow, and you call some random API. Inside them is actually a bunch of metrics multiply. If you know how to write CUDA code on a GPU, you go one level deeper. You know exactly how each of these function calls from PyTorch or TensorFlow actually work and how you actually multiply them fast on a GPU, right? So let's come back to the context of this class and the fact that these fields are in high demand. What does it mean? If you know how to do these things, or if you have a project related to these things, you're gonna get a really good job because not many people can do that, right? There's tons and tons of people who know how to use PyTorch or TensorFlow because they took like random machine learning workshop. But they don't know what that black box inside is being constructed. You don't fundamentally understand it. This class, hopefully we break that black box and expose it to all of you so that you understand, oh, okay, this is actually how it works. That's why it actually performs really well. Okay, so hopefully I sell this idea. Sorry. Key message of this slide is, for your project, pick something interesting and make it faster. Right? You can check with me after class. Anything that would aid learning for you, I'm more than happy to guide you on that. All right. So we'll use primary two languages, Scala and Rust. There is 1 to 2 lecture that I'm going to show you some example code on C++. So that I can show you, hey, another different library that you can use to run parallel program is OpenMP and pthreads, right? These are two different really common C++ tools, framework libraries that allows you to write parallel program and see how it works. So you will mainly use Scala or Rust, but you're open for your project. You're open to use any languages. For the in-class exercise, there'll be both lecture slides and coding exercises. Lecture will be at most 1.5 hours. Usually, this will be around 1 hour because I want to make sure you get to actually code things on your screen. We will switch to in-class exercise once the lecture portion is over. So please work on things I ask you to work on. It actually helps with homework. It helps a lot. The reason why I said that is this, every single semester, people who actually got an, like, I would say A, like 100 after curve or more, are those who actually did the in-class exercise. And they asked questions that ran into, and it helps with their homework, right? So here's my expectation. This, again, is a junior/senior level classes. So unlike the system skill, where some of you might have been through that class with me, there'll be a lot of new way of coding. So to be honest, the way you write a functional programming or functional programs will feel so different from anything you've been doing so far. Python, C, Java is different. I appreciate the fact that you hate recursion, so please be aware there's a lot of recursion. We'll go through this together. That's the in-class exercise to practice on this. This applies to both the assignments and the projects, right? Anyone here go through system skill and hate this thing called segmentation fault? Can you raise your hand, or malloc in general? Yeah, I see some hands. You will not run into that. I assure you, there's no more segmentation fault. another another annoying thing you run into in this class is different. Now it's be more like I want to compile the code, but the compiler is smart enough that your code is buggy, so it won't let you compile. It's a totally different way of thinking. Functional programming allows the compiler to detect potentially buggy code, and it won't let you run the program. So you're gonna think a little bit differently. You're going to be careful about type, for example, a lot more than in C. Workload will be on the heavy side. Start your assignment early is always a good idea. Always. My trick is at least read the assignment so I can gauge. All right, if I want to procrastinate on this assignment, how many days do I need to allocate for it, right? And make sure you maybe double that or like put like 1.5x on that number. Otherwise, you're gonna run into some surprises. And you should have a good grasp of the intro to programming. By this time, you should be able to write things in Python. If not, I'm sure you can learn Python in a week. It's not hard. You should be able to know intermediate programming like Java or C. If these are things that you are like, if you have no clue on these two topics, talk to me a little bit so I know where you are and so I can recommend the right course of action, because I don't want you to run into a situation where you take this class for like 5 weeks already and like, okay, too hard, I can't do the first assignment. That sucks for everyone, right? And you should have some basic computer system and hardware. What do you mean by basic on these two topics? System skill. Anything that we cover there, if you have those, awesome. That's it. Why do I ask you to have some basic on this? Whenever I want to talk about performance, knowing the memory hierarchy, which is the main source of performance overhead, allows me to make it much more clear on what exactly happened. All right. So what will you learn? The goal of the course is you should be able to know, again, the essential concept behind programming language, blah, 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 parallel programming, and how to increase performance, right? That's it for the administrative stuff. We'll actually start to dive into the content of this class. Any questions so far? All right. So if you have questions, feel free to raise your hand. Don't worry. Interrupt me all you want. I enjoy it actually. Type the question, raise your hand. I really encourage interaction in the class. I know this is not like online thing. It's not as ideal as having this in class and you can raise your hand, ask random questions. But I love it basically. It just allow me to actually gauge whether you got what I say or not too. So if something I say is not clear, feel free to. Oh, you haven't texted skill before, and that's okay. That's totally okay. So have you taken at least the Python class before, the intro to programming or like write program in Java? Yes or no? Okay, then you're good. One thing I can tell you is Syscale will only the last module of Syscale is allowing you to kind of like see, oh, okay, that's where the performance come from. That's it. It's actually just might be a little bit more picturestic. That's how I should put it, I guess, to understand concepts of we learn in this class. But I have another way to make sure you understand it. So don't worry too much about that. It actually just translates to, well, you see the source of where the performance come from. And it only matter about the project part of the code. Okay. So personally, that's a great question because that's something I'm so suck at. So that's a great question because I typically just use Vim and I'm not ashamed about it. I use Vim for everything. And yesterday I was thinking of it, Ajahn Sansern and Ajahn Kanat, for the Comsys Art class. And Ajahn Kanat was like, oh, he has this like cool IDE that work on Syscale. I was like, it's awesome. So I'll check with I'll check with someone who might be able to actually do an office hour and show a good way to set up the IDE. Because my personal experience on using IDE is so limited. The last time I used the IDE was about 10 years ago. The rest are like I go to the server and use Vim. And this is really, really important for the class, basically, particularly this class. So I'm gonna ask my TA for the class. So if you know Pupa, basically he's our TA. He actually has a really great setup for both the IDE side that somehow work with his really, really tiny memory machine. So it won't take all the resources, as well as the setup on the syscale side that would allow you to kind of like highlight function name and things like that. And on syscale, there's also another build where Ajahn Kanat did. It allows you to use a mouse and also like complete the function and things like that. It's really, really fancy. So I'll do that. That's a great question. I'm gonna follow up on that. It's likely sometime either next week or the week after. All right. And if I disappeared off, I forgot. Justin, do you mind reminding me on that? Just in case. But these are great questions. All right, cool. So any more questions about the administrative stuff? Again, don't worry about not having tech syscale before. Everything you learn here is gonna be pretty new. If you have done Python and Java, that's basically about the roughly. Wait, did you take data structure before? Because that's a much more important class. Okay, if you take data structure before, you're good. Because we're gonna cover how to write some of those structure in using recursion. So I don't intend to like cover data structure. I'll cover data structure in the context of recursion. So it's a solo project unless you want to tackle a much bigger project. So if you want to group up, I'm open to that, but it has to be harder. So talk to me if you want to group up for the project, right? So I welcome any format for the project. But if I'll have the roughly estimate of like amount of work per student that you have to do for the good, basically full credit on the project. And then I'm gonna kind of scale it based on number of people in the team. Right? So if you want to do something crazy, feel free to. Feel free to recruit your friends to work on the project, and I'll basically talk to me so I can kind of like figure out how much work should be done for the project, or like what are the extension that would be interesting for the context of your project and things like that. All right. So yeah, so hopefully that's answered the question. Any other things that you want to ask? Okay, so let's dive into. Oh, yep. So let's just. Oh yeah. So please. So if you don't have the syscale account, so email me at myname.a at tg.kmutnb.ac.th with your student ID. Email your student ID. It will be your account will be you followed by student ID. Right. So I will create this. It doesn't take more than like 1 minute to do it. So just email me with that. I will make sure we create an account. I'll let you know how to log in. And please, after I send an email, test the login and change the password. Why do I have to change the password? Just to make sure your friend doesn't like throw you a lock into your account and do something weird with your own like home directory, right? Uh, and I guess after 2 weeks that I created your email, I encourage everyone else to kind of hack into your friend's account. If you are able to do that, let me know so I can reset the password and you get some extra credit. So, all right. So to all your friends, be the police and help me check if anyone here forgot to change their password. Right. Okay. So let's assume that that's okay. Any more questions? Feel free to put it on the chat. I'm gonna keep addressing them. Feel free to. I basically look at the chat all the time. That's why I'm looking that way, which I know is kind of weird. So the first thing that I want to cover for this class is let's go through some historical context, right? The early day machine. Anyone here watch Imitation Game before? The movie. All right, that's a like button. So I hope at least some of you watch it, some of you hopefully like it. I like it a lot. I mean, it's definitely worthy of Oscar nomination, which they got nominated. So that's one of the early day machine. It's real. It's actually that advance in hardware, right? If you look back in the historical context, there's this new, well, not new anymore. The old machine called, like, for example, ABC from Atanasov and Berry. Sorry, I murdered his last name with my pronunciation. There's a Suzy machine, C3 and C4. And then that machine in imitation game is called the Colossus, invented by Alan Turing. So the name in the parentheses is the inventor name, right? So we all now know that Alan Turing invented, well, I mean, as definitely a co-inventor, there's a team of engineers who built it, right? But one of the lead team is Alan Turing, who built the Colossus. And if you haven't realized that, he made also many other contributions to computer science to the point that we actually name him with the biggest award you can ever get for computer science. It's the Nobel Prize for computer science. It's called the Turing Award, right? So there's also the machine called ENIAC, right? If you read the old Thai textbook on like computer, many people would say, hey, ENIAC is the first computer. If you think about it, well, it's likely true in some context, but there are also other machines being developed around the time. For example, the Colossus, which no one know it exists until I think after they retired the document saying, hey, the English actually built another computer to help in the war effort, right? There's also EDVAC invented by von Neumann. We will talk about this name a little bit because he is also another really important figure. Von Neumann invented the paradigm for the programming that we use nowadays, right? We call it iterative programming. Then, if you take the SysSkill class, there was a big modules on assembly. And one thing you learn from assembly is how your program is in the main memory. The first machine that actually does it is called EDSAC, invented by Wilkes. And this is actually the first store program machine. And these are all in the 40 to 50 to 60. So these are old machine. And then there's ideas on all this like emergence of new hardware, right? So these are all in the like 40 to 50. And one thing, so for those of you who watch Imitation Game, did you see how the machine run? That have like this rotating disk and it's a large machine. When they program it, they kind of have to manually input the input, right? So those are the early day machine. There's no software about it. There's no context of software, right? Think of it this way. Basically, the way you program the machine, you can't really program much of it. You tell the command, the machine do some command. It's like a really fancy calculator. And then there's an emergence of programmable software. It allows you to program things like Fortran in 1954. Anyone heard of this language before called Fortran? So yes, awesome. So I appreciate raising your hand. So these are one of the, well, it's the first language actually, but it's a language that is still, I think, being used in some of the space component in the used by NASA. At least that's what I've heard. But if you think about it, the programming language changed a lot from those early day machine, right? Why? Why is that? Language back in the day will mirror hardware concepts, right? It mirror hardware concepts. Basically, the hardware can do X, Y, and Z. The language should allow the programmer to just do X and Y and Z, and that's it. Why is that the case? The machine that you see in the movie or in the museum, those are super expensive. Think like say quantum computer right now, right? They are super expensive. It's not easy to program. So you can hire tons and tons and tons of programmer because they're cheaper than a machine, right? Parts are costly, and the program has to be really efficient from the get-go. So you will interface with something similar to say assembly. Back then we used punch card, right? We used punch card to program things, and the programmer would just squeeze their brain out to figure out how to program this machine. Now, if you look at the language, it's actually now be a center of the design concepts, right? You can have things like object, record, function. We'll talk about record in this class as well, but you have functions. It actually is more reflecting more like a math component, right? What you want out of the program. Why is that the case? Because machine is cheap, and it will become cheaper and cheaper and cheaper, right? So why is it cheaper? Because when we design hardware, one of the target that we all have to meet, for example, if I try to publish a paper in a computer architecture venue, they'll ask about cost. How much do I have to sacrifice in order to get those kind of performance gain, right? So all the company, Intel, Apple, Qualcomm, Huawei, right? All these big hardware company, they have to think about the cost trade-off, right? They have to come up with a chip that is really efficient. Why is that the case? Because people now cost way more than the hardware. Scripting and efficient code. Anyone here seen ugly code before? I mean, have you looked at the first piece of code that you wrote like back in the day? Anyone here realize, okay, that's kind of look ugly. Anyone here write like a big chunk of if else everywhere? Come on, I did that too when I was like first year, second year. I do it now in many cases that whenever I feel like I need to, right? But in efficient code, well, they are okay and quick to develop, but it's better to make the program more efficient, right? And these days, the language are being optimized for all the resource constraint and design goal, right? Anyone here want to make a guess of like if you go to the Silicon Valley with an undergrad or a master degree, how much will you get paid per year in dollars? Anyone want to make a guess? Let's say you go to Google or Facebook. Roughly that, yes. Around 100K is a lot, right? So divide that by 12, you get about 10K a month. So a company needs to think about it this way. You as a programmer need to be able to produce the value to the program that worth more than that. Otherwise, you'd lose all the profit margin, right? Think about it this way. Programmers' time is much more costly. 100K, you can buy at least 12 really, really, really fancy computer, right? So you as a programmer now worth more than that. That's why programming languages are being designed to minimize programmers' time. Anyone here like Python more than C? Oh, assembly. Anyone here like Python more than assembly? Yeah, everyone, right? Me too. Yay. So that's a fact. It is a lot easier to implement certain features that you want to implement for your program in Python rather than in assembly. And why? But in the end, right? Why do you want to have so many languages? Do you say you have Python, Scala, Rust, C, C++, C Sharp, assembly, right? Each one of them, actually, if you look at the concept behind programming language, it offers different trade-offs. Easy to use. Python is really good at that. Before the days of Python, it was Ruby. We don't use that much anymore. And then Perl, which is even older, right? So that these scripting language that allow you to actually build something quick. Safety, we learned this through Rust. They're really, really, really fast languages. And they're safe languages too. So if you think of malloc and segmentation fault, using Rust would make your life a little bit easier on that front. But then we'll have some trade-off. Some certain element of Rust are not as easy to program. You still need to think in the functional way, right? So functional programming is a good basis for that. Performance. C is really fast. Why? It doesn't really have the element to give you different APIs, the feature to convert certain things, right? C is a pretty much, I would say, what you see is what you get kind of language. You tell them do this, they'll do exactly that. And there are design trade-off, right? Some of the syntax and the complexity of the code can be different. Python is easier. They'll try to detect potentially where you might have bugs, with the exception of that tab thing that I hate still. Where you need to make sure if you have a loop, you need to indent like one level. There's no this open bracket. This is a weird thing about Python that I still don't like. Semantics, right? Anyone here heard about the word syntax and semantics and curious what are they? Anyone here has heard the word syntax error before? So you might have seen the word syntax and semantics before. Right, when you go through a textbook and they might talk about that. What are they? Well, I mean, if you're curious, I'm gonna compare this to English, right? Or Thai, actually. But I think English is a little bit easier to compare, right? If you write a sentence in English, let's say I need to write an essay, right? One essay, like 5 paragraphs. Syntax is equivalent to I have everything grammatically correct. What does it mean that if I have grammatically correct sentences? It means that I don't miss on things like subject-verb agreements. I don't miss things like the articles and the use of articles. I use proper preposition. I use the subject, verb, object format. I don't start with a verb and randomly with an object and then a subject like a Japanese language, unless I'm writing in Japanese, right? So that's the syntax. When you see syntax error, it means that the computer screams back at you, I don't understand that line because I am not capable of parsing that text that you just put in. One of the most common syntax error in C, for example, is you miss one semicolon, right? That's a syntax error. C assume that you need to end your command or sentences with semicolon. It's similar to in English, you would expect the end of a sentence with the dot, right? That's syntax. Semantics means that if I write that essay, I know exactly what does essay mean. It doesn't have to be syntactically correct. Say if you read my own writing, right, in English, because I'm a Thai guy, I never really properly have a good English education until I actually went to the US, right? And even then, it's still like I'm still bad at it. You see a lot of grammatically incorrect things in my writing, right? But that's fine because at the end of the day, if you read my text, you know what I'm trying to say. That's the semantic information. I read through the text, I know exactly what I'm trying to say. So the same thing happened in your program. I stare at your code, I know what you're trying to do, or at least I hope I know what I try to do. These two things play a big part of how you can write a compiler and how can you optimize your program from the compiler point of view. There's also different paradigm that each of the language favor, my bad, sorry. They favor different thing. For example, right, C would favor iterative paradigm. You go one line, next line, next line, next line, next line. Functional programming would favor dataflow paradigm, which we're going to cover in a bit. Right? Each of these paradigms leads to different trade-offs. Iterative programming like C, Python, and Java are easy to think about. Functional programming is a little bit weird, but they're also not too hard to think about, but they rely on things like recursion, function call. They also have the type system and type rule, right? Anyone here seen the warning of listen, if you write a program in Java or C and you come across a warning and say, warning, potentially incorrect type, in the illegal casting from a character to an integer or something like that. You might have seen that before. These are data type. A data type. Data has different type. Character, integer, floating point, right? They have their own rules, and each language has a different how strict they are on those rules. They also have a different memory management. Malloc is a big flavor in C. You get to control a lot of the memory addresses that the OS throw at you. Many other languages like Python, you don't even have to care about that. Right? Python would automatically manage this for you. Right? Some language doesn't even need a compiler. Python is more like a interpreter languages where you type in one line, you can actually just run that one line. Okay, there's a package delivery to me right now. Let me answer to them quickly. I'll be right back. All right, sorry, my cat bears arrived, and disclaimer, there's a non-zero chance that somehow I have cat jumping in front of me in your screen. That happened before in all other classes that I've been teaching. Quick warning, don't go. I can control my cat. Anyway, so I'm back. So some of the language doesn't really require a compiler, right? And then there's also emergence of this concept called parallelisms, i.e., making your program run faster through running many things in parallel. Anyone here remember the back in the old day where you have the Pentium 2, Pentium 3, Pentium 4, and everything you cares about is all about that gigahertz. How fast is the clock? Oh, am I too old? That was around 2000, year 2000. Maybe I'm really too old. Okay, so back in the day, we don't have multi-core in many home use computer, right? You would go and buy an Intel Pentium processor or Intel Pentium 2 processor, Intel Pentium 3 and Pentium 4 processor, right? And if you zoom in, somehow you can magically zoom into those design. You see that it's one core. And everything Intel is trying to do is make the core faster. Until one day, Intel realized that, okay, if I keep making this one single core machine fast, my chip would require a nuclear power plant to power that because it's exponentially growing in terms of energy consumption, right? So what is that solution? Well, has a weaker core, but 2 of them, 4 of them. These days, how many cores do you have on your computer? 4 to 8, 4, 6, 8. These are common number, right? So these are the emergence of multi-core. With the emergence of multi-core, it also allows you to run things in parallel. So if you look at the classic von Neumann model, remember the name von Neumann, right? The reason why we call it because he kind of invented this store program counter, store program computer. These are the most common way to actually basically run a program. Why? If somehow I tell you and I give you a list of, oh sorry, how about I give you assignment 1 and say, step 1, do this. Step 2, do this. Step 3, do this. Step 4, do this. Is it easier comparing to I throw you an equation and say, solve it? Which one is easier to follow? Is it the first kind of paradigm where I tell you step 1, do this, step 2, do this, step 3, do this, step 4, do this? As opposed to I throw you an equation and say, solve that equation. Somehow you can understand the math. The first type is going to be easier, right? I just follow all the steps and somehow I got it correctly. So that's the von Neumann model. You tell the computer that 2 key properties. First of all, the program are stored in DRAM, the memory that you buy, right? And then the memory is unified between instruction and data. What does this enable? What does this enable? The key here is this. You process one instruction at a time. You go line by line by line by line, right? Is that the same way you process Python? Is it from the first line, then you run the second line, and then you run the third line? Is that the case? Yeah. So this is the von Neumann model. Python, Java, C, C++, most of the language in the world follow this model. Why are they good? Why are they good? From the human point of view, from the human point of view, it's easy to follow. I can write a program because I know exactly I need to do this first, followed by this, followed by this. I can write a program that way. Is that the only model? Nope. Right. That's not the only model, but it's one of the most dominant. So most of the assembly instruction set architecture, which is think of it as assembly code, we use this model. Intel x86, AMD x86-64, basically all your computer that use the Intel chip use the AMD version of x86-64. If you're curious why that's the case, I can tell you the historical context on how Intel failed to actually extend to the 64-bit and AMD caught up. ARM, which will Nowadays, it's being used in many places, including the NVIDIA GPU. These days, they have the ARM chip next to it as well for some high-end GPU. Or commonly these days, the Apple M1 chip. They use the ARM processor. MIPS is a simple processor that we'll use as a basis for the computer architecture class, not the required one, the special topic one, in case anyone want me to open that. We'll design a way to simulate MIPS processor. You build something that run MIPS program. Spark is another common processor for server machine, including the IBM Power. Alpha is another common back in the day old machine before Intel and Apple and kind of take over the world. What is the alternative to von Neumann? If you think about it, right? If you think about it, programs are functions. Functions are maps, right? So if I say this, if I have an equation like this, or something, right? If I have this equation, I have input x and y and z. I said compute this. I said compute this. What do you do? Which one do you do first? So let's say I'll say x equal 4, y equal 10, c equal, I guess, x plus y, right? And this is a negative sign, my bad, not the equal sign. So what do you do? Which of this are you going to from left to right, or are you doing the x plus 2 and y plus 4 together at the same time? So that's my question, basically. Which one do you do first? Left to right. What if I have two adders? What if somehow your brain is capable of doing two adds at the same time and two subtract at the same time, two operations at the same time? Which one do you pick to do first? X plus 2 and y plus 4, right? Yeah, you process the thing in the bracket first, right? It's not left to right. There's no strict order in terms of appearance. It's not like first line, second line, third line, fourth line, right? You look at that equation and see, okay, I'm going to break it down to see which one is ready for me to compute, right? So does it make sense that, hey, you don't have to go line by line by line. If you look at this equation, you can do each of the things. Some of you might do it. Okay, I'm going to replace C with X plus Y. So that's the first thing you've got to do, X plus Y. That's the last thing that comes in the equation. So you can do this order. First, I'm going to compute X plus Y. What's that? 14. Then I'm going to compute X plus 2 and Y plus 4. That's 6. And that is, what's this? Y plus 4, 14. Right? And then you compute the rest. Right? It doesn't have to be in this strict left to right order. Right? As long as I have the value of what I can compute, I will compute it right away. This is called the data flow model. This is called the data flow model. Von Neumann model means that I will execute the instruction in what we call control flow order. First line, second line, third line, if else, jump to the else, continue on. 10th line, 11th line, 12th line. There's a strict ordering of which come first, which instruction come next. If you in syscue, there's like this instruction pointer that grabs the next instruction. And if you have if else for loop, you go based on the condition, and that's it, right? You have for loop to have the condition check. If true, keep running. If true, keep running. If false, get out of the loop. Go to the next line. The data flow model is basically will run your program by assuming that whenever I have the data, I'm going to run it right away. It doesn't have to be the 10th line, right? It doesn't have to be the first line first. You can run the second line, followed by the first line, followed by the 10th line, followed by the third, fourth, fifth line. In any order, whenever my data arrive, I will run it right away, right? You compute when what we call the operand, the input to your function, right? The input to your function, whenever that becomes ready, I do it right away. So for example, if I say f of x and y equal x plus y, if I know x and I don't know y, can I run this? Can I run this f, function f? If I only know x and I don't know y, can I get the value? No, right? I can run it whenever I have both x and y. If x is 5, y is 10, I can return 15, right? So you compute when the operands, the input to your function x plus y, what's that? The input, the left side and the right side of that plus sign. When they are ready, I run it. There's no concept of instruction pointer. I just run whatever is ready, right? The ordering depends on data flow dependence. The reason we call this data flow dependence is everything is based on whether I have the data or not. If the data is ready, I run it. If the data is not ready, I hold it off and don't run it yet. Think of this as a math function or something that just draw earlier, right? It's a math equation. It's a math function. So whenever I have the inputs, I compute them. Many instructions will be able to execute at the same time. This is where the performance comes from. I can tell you one thing. So this is not the topic I'm going to cover in detail until the special topic class, which if we have more than 7 students, I can open that. But the way your computer runs things, you write the program in von Neumann, then your chip would convert that to data flow to make it faster, right? That's why functional programming, which kind of follow this data flow model, make it faster because you don't write things in iterative programming or von Neumann model, and you don't have to do that conversion. Programmer already will do that conversion for you. So here's the comparison. Sequential von Neumann, if I see the one on the left side, right, the order of how I do things are, I will run this first. I'll run this second, I'll run this third, and then I'll run the last line. Right? Anything clear so far? You first run a plus b, then b multiplied by 10, then b plus x, and then c plus y. Right? Any questions so far? So that's the von Neumann, the program that you are familiar with so far. Python, C, Java is written this way. A data flow model would look something like this. If you look at the program on the left, right, you see A and B. Okay, I'm going to add them together. But if you look at the second line, can I compute C and X at the same time? If I have B and A, can I compute both C and X at the same time? Yes, right? So that's the beauty of data flow model. You know, okay, these are independent operations, so I can run them in parallel, right? So you do both at the same time. What's the next command? Next command first, it rely on if we have B and X, right? So we have both B and we have X, which is B multiplied by 10. So you can do that. Then data flow model again dictates that this fourth instruction C, because that depends on Y, right? Because that depends on Y, you have to wait until the last operation finish, right? So my question is this: which one of these two models are more natural as a programmer? Which one do you prefer, the left side or the right side? All right, so do you like the left side of programming more or the right side of programming more? I think most people, if you do Python, Java before, you like the left side. Now we're going to teach you how to do more of the right side. Why is that the case? This thing takes for, let's assume each instruction takes for cycle of the CPU processor, right? If you look at this, I only take these 3 cycles, right? 25% faster. So now do you know why on your chip, even though you write things in Python, C, Java, we hardware designer convert your left side to the right side. This is done already, right? In most chips. If you want to go into more details, feel free to let me know. I can go on and on with how these things are designed. But the benefit is clear. The left side is a lot more programmable. It's easy to program as a human. The right side is faster. So today we're going to kind of wrap things up with data flow model. So what are the different types of data flow node that just draw? There are things like computation. You have A and B, multiply them together, you get an output. There's things like conditional and relational. Conditional is you test the input. If it's true, go left. If it's false, go right. Relational is just comparison, basically. If A is less than B, you give the value true or false. Usually when you draw this together, this thing connects here. So you know exactly this true or false go into the conditional part. It's if else, basically. And sometimes you have a lot of like parallel program going on. There's also this barrier on synchronization where basically you say, wait until every one of these input becomes ready, then you proceed to this barrier, right? So to make this a little bit more clear, we'll end the class with this. This is our first in class, but it's a group exercise. So you all will work together. Any preference on Discord or here? Because I figured Discord is a little bit easier to kind of like yell things out loud. So, and I can be there to kind of like help you and guide you through what is this thing. So I'm gonna post the slide right after this, so you see the this picture. Your task is figure out what this data flow program do, right? And my hint is do the left side first before the right side. All right, so I'm gonna post the PDF and we'll migrate over to Discord. But before we leave today, there's one more in-class exercise, which is make sure you install Scala, which is the main languages that we use for the first half of this class. There's a download at Scala-Lang. If you use, I think IntelliJ, there's also built-in for that. I never use it personally, but I can basically check with our TA, Pupa, which done this before, and try to run the following code, which is just hello world. Simple, and it should hopefully print hello world. And one more thing is Scala is kind of like Python, which is a REPL language. Repeat, evaluate, print loop. Basically, you can run one line at a time. So this is called REPL. And expression can be entered directly into REPL. We'll go into what is an expression in the next lecture on Thursday. Hopefully we have Zoom by then. Anyway, so before we finishing up the lecture, let me save this and put the PDF onto the class website. So let me export this to PDF. All right, publish, and should be posted really, really soon. In the meantime, let me stop the recording so that it can be processed and I can post it on the